In this video, we will discuss one method of making a buffer, where we begin with a certain quantity of weak acid and add strong base to make the buffer. We will make an acetate buffer that has a pH of 4.00 by starting with 500 milliliters of 0.482 molar acetic acid and as much 9.50 molar sodium hydroxide as needed. We will determine the quantity of sodium hydroxide that is needed to make this buffer. The first step in any buffer problem is to write out the Henderson-Hasselbalch equation, where pH is equal to pKa plus log of the ratio of moles of base to moles of acid. In this example, pH is equal to pKa plus the log of the moles of acetate, the buffer base, divided by the moles of acetic acid, the buffer acid. The moles of base is what we will determine in this problem. We calculate the moles of acid based on what was given us in the problem. 0.482 molar acetic acid times 0.5 liters is equal to 0.2410 moles of acetic acid. Because we already have weak acid present, we need to add base to create this buffer. If strong base, for example sodium hydroxide, is added, it reacts with the conjugate acid, such that acetic acid plus hydroxide yields acetate plus water. Thus, the moles of acid will decrease as sodium hydroxide is added, and sodium hydroxide will create conjugate base. If the quantity of base added is X, then the moles of acid will be 0.2410 minus X, since acid is consumed in making base. Since the quantity of base added is X, then the moles of acid remaining will be 0.2410 minus X. In the Henderson-Hasselbalch equation, we see this as 4.00, the pH, is equal to 4.756, the pKa, plus the log of X divided by 0.2410 minus X. We then solve for X by rearranging the Henderson-Hasselbalch equation, removing the log, and cross-multiplying. We find that X is equal to 0.03596 moles of base that need to be added to make this buffer. 0.03596 moles of hydroxide will come from the sodium hydroxide available to us at a concentration of 9.50 moles per liter. Therefore, we need 3.79 milliliters of sodium hydroxide to create this buffer having a pH of 4. As we add the sodium hydroxide, it will convert the buffer acid that's already there into buffer base, the acetate, in such a quantity that the pH of the buffer will be 4.